How many times have you arrived at the airport early only to miss your flight due to the security line? Security lines. Something I never thought I would miss. Anyways, while traveling by airplane is the fastest means of getting from point A to point B, many times we spend more time at the security checkpoint than we do in the air. There's tricks of trades, of course. Seasoned travelers like myself spend a little money and some initial inconvenience with interviews to get trusted traveler credentials, allowing us to bypass the majority of the security lines. This doesn't completely remove delays, but it sure improves the experience. This security is important and necessary, keeping us safe at the cost of time. This is a great analogy for security in the data center. It's inconvenient and adds extra cost, sure, but necessary to keep data safe. The wrap on security in the data center is that it's expensive to deploy, confusing and difficult to set up and manage, and a burden on performance. Today, I'm going to tell you that it's more costly to not have a security plan, that KIOXIA and Dell EMC have taken the challenges of protecting data at rest out of the equation, and with KIOXIA's SED and FIPS SSDs, there's no impact to performance. I'd like to introduce Tom Hibler from Dell EMC, responsible for their SSD product management. He's going to go through a quick introduction on Dell's 2021 SSD strategy and SSD security options. Take it away, Tom.
All right, thanks, Matt. Hi, my name is Tom Hibler, and I'm an SSD product manager with Dell Technologies. Today, I'd like to walk you through our 2021 SSD strategy. So let's get into it. We have three main pillars or focus areas for 2021 when it comes to our SSD strategy. The first one is more security offerings. So we're going to have FIPS and SED available on NVMe on our Isilon products and also on PowerEdge available through our RCI process. We're also going to be adding SED as base, which means all of our value SAS offerings are going to be SED enabled for our value SAS swim lanes. This is a total of 7 new read-intensive and mixed-use SED offerings on value SAS. Dropping down to our enterprise SAS swim lane, we're moving to a FIPS as base strategy, which means we're going to have 3 additional new FIPS offerings for a total of 7 read-intensive and mixed-use enterprise SAS drives. Dropping down into higher performance, so we're going to continue to expand our value SAS and data center NVMe portfolio, which we're going to get more aggressive with our pricing on to compete with SATA. We're also going to be introducing some larger capacity drives. So on our SAS mixed use and our NVMe read intensive, we're going to be offering some larger capacities than we have previously. So hopefully we've got some new offerings that'll help fit your applications. So now I'd like to get a little more on the encryption piece. So encryption is really one of our main focuses for our PowerEdge portfolio as well as our SSD portfolio. We get quite a few questions on our different encryption offerings. So on this slide, I'd just like to walk through the difference between an ICE drive, an SED drive, and a FIPS drive. And I know Matt has some more details on this later. But just real quick, a FIPS drive is basically the same as an SED drive. The only difference is that NIST government certification, that FIPS 140 certification. The other key call out here is that all these drives, the performance is the same. So there's no delta between an ICE and a FIPS or an ICE and an SED. No matter what level of encryption you have on your drive, the drives will all perform the same. And as I mentioned earlier, our value SAS offerings will all be moving to SED as base. And on our enterprise SAS, we'll have FIPS as base. And then, of course, on NVMe, we're introducing both SED and FIPS. So lastly, I'd like to show an overview of our portfolio and how those FIPS and SED offerings are woven in. As you'll notice, more than half our portfolio now is SED and FIPS enabled. And here you can see value SAS with our SED as base offerings, SAS with our FIPS as base offerings, and then NVMe at the bottom where we also just recently enabled SED and FIPS. So that's a quick overview of our 2021 strategy. And with that, I'd like to turn it back over to Matt from KIOXIA.
Thank you, Tom. What a great lineup. So I haven't introduced myself. My name is Matt Hallberg, and I'm a Senior Product Marketing Manager here at KIOXIA, formerly known as Toshiba, and responsible for our enterprise NVMe SSDs, and have had the pleasure of working with Dell EMC for years on growing NVMe into the data center. IBM and Ponemon Institute's Cost of a Data Breach 2020 and Varonis's 107 must-know data breach statistics for 2020. I've included some links in the slides in case you want to go check those reports out for yourself. In 2020, the worldwide average total cost of a data breach was $3.64 million. And in the US, it was $8.64 million. There have been some high-profile, expensive costs for data breaches in the last couple of years, with Experian topping the scales at $575 million from the FTC alone. On a recent earnings call, Experian believes that the costs are now well over $1.4 billion. That's a lot. When Marriott was hacked in 2018, 500 million customer records were affected, including mine. Marriott International reported that it had booked a $126 million charge in 2019, not including the additional revenue lost from customers no longer trusting the hotel chain protection of their personal information. This $126 million includes $115 million in class action suits, $31 million in lawyers' fees, and $26 million in fees levied by the Department of Health and Human Services. Anthem's medical data was breached in 2015, impacting roughly 78.8 million patients. Fees and settlements were heavy, and Anthem ended up losing around $162 million. The healthcare industry in particular is particularly sensitive around customer data, with regulations like Health Insurance Portability and Accountability Act, HIPAA, demanding large fees for data privacy violations. The average cost of a data breach in healthcare in 2020 was $7.13 million. Other regulations, like the General Data Protection Regulation, or otherwise known as GDPR, impose heavy fees for compromised data. In 2020, there were 3,950 reported data breaches. 80% of those breaches included data containing personal information. Intellectual property was next at 32%. Some of the high-profile data breaches have been Facebook in 2019, exposing 540 million user records on a cloud server, and Yahoo owns the record for the largest data breach of all time, with 3 billion compromised accounts. And it's not just the large corporations being targeted either. In 2019, Georgia Tech, known as a tech-savvy university, was breached for a second time in less than a year, exposing a database containing names, social security numbers, addresses, and birth dates of 1.3 million students and staff. It's a scary world out there, and you need to have a plan for protecting your data, or the cost of fees, customer confidence, and regulations will certainly be more than not investing in data protection. So let's talk solutions. First, I want to explain some of the security terms you may see or hear about for SSDs. Tom took a brief view of them, and I'm going to expand on that. KIOXIA, via Dell EMC, offers 3 different security levels when adding KIOXIA's PM5 and PM6 SAS SSDs and CM6 NVMe SSDs to your servers, ISE, SED for SAS only, and FIPS 140-2. I'll explain what each means and an overview of how they work. ISE stands for Instant Secure Erase. Securely erasing your drives means a couple different things, depending on how you use the command set. Crypto erase is commonly associated with ISE drives. When reading and writing to the SSD, the data stored on the SSD is encrypted data. The SSD uses what is known as a media encryption key, or MEC, and an advanced encryption standard, AES 256-bit cryptographic module to encrypt the data as it is written, and uses the media encryption key to decrypt the data as it is read. When you use a secure erase or sanitize command, you are deleting the media encryption key and making a new one. Since the previous media encryption key was used to encrypt the data on the drive, now there's no way to decrypt the data and it is considered useless. This method of erasing the content on the drives is much faster than using a normal format command, which erases the data on the drive by returning it to the original factory state, reducing the SSD's overall drive endurance. While it may seem comforting to know that the data on the drive is encrypted, it's not always protected from anyone accessing the data at rest. The media encryption key is symmetrical, meaning it is used to encrypt and decrypt the data at rest. The host has no management nor access to the media encryption key at all. It is internally generated, stored, discarded, destroyed, and refreshed by the SSD. This is where the next level of security is needed, SEDs. Self-encrypted drives, or SEDs, or FDE, full disk encryption, use an authentication scheme to give IT administrators the ability to protect the drive by assigning an authentication key, or AK, requiring this key to lock and unlock access to the user data on the drive prior to the data going through the AES crypto block. There are security command sets associated with this process, as defined by the Trusted Command Group, or TCG. These commands dictate management, activation, and provisioning of the user data. These specifications also include data structures and the required content, as well as mechanisms for managing and configuring authentication credentials and access controls. For SaaS SSDs like KIOXIA's PM5 and PM6, that command set is called TCG Enterprise. For NVMe SSDs like KIOXIA's PCI Gen 4 CM6, this command set is called TCG Opal. These SED drives are fit for most applications and regulations that require the data at rest to be encrypted. Here's a chart that shows how this works inside of our SSDs. For an ISE drive, the data passes through the crypto engine and the data written to the SSD is encrypted. When the data is read, it goes through the MEK and AES 256 crypto module and is given to the requester as unencrypted data, also termed as plain text. As I mentioned previously, there's nothing restricting anyone from reading and writing to the ISE drive. The next section in the graphic is for an SED. For an SED, authentication key and authentication credentials must be exchanged and validated prior to allowing access to the data on the drive. If the drive is not unlocked, it does not allow access to the data on the drive. There is one final tier of security available, FIPS 140-2, or Federal Information Processing Standard 140 Publication Series 2. What a mouthful. It's a set of standards and guidelines developed by the National Institute of Standards and Technology, otherwise known as NIST. These drives are typically for the U.S. government or companies and agencies dealing with the U.S. government. The use of validated cryptographic modules is required by the United States government for all unclassified uses of cryptography. If the cryptography modules are not validated by NIST, then NIST views the data on the drive as unprotected plain text. If the agency specifies that the data at rest must be cryptographically protected, then FIPS 140-2 and/or FIPS 140-3 is required. In order to achieve FIPS 140-2 and 140-3 certification, the SSD vendor and/or system, software, platform, etc. vendor must undergo a review and validation of the cryptographic module specification and documentation, key management, including generation, entry, output, storage, and destruction of the keys, cryptographic module implementation, design assurance, and mitigation. Here's a chart that shows the process. So the vendor, like KIOXIA, designs and produces a cryptographic module that complies with the requirements specified by NIST and FIPS publications. We would submit the modules and associated documentation to the Accredited Cryptographic and Security Testing, or CST, laboratory of choice. Any changes made to the crypto modules after validation results in a new submission. At the CST labs level, this is a third-party lab that's been accredited by NIST. The CST labs independently test the cryptographic module to the appropriate FIPS 140-2 or FIPS 140-3 level. They conduct the algorithmic testing, they review the cryptographic modules, documentation, and source code, and they perform the operational and physical testing of the module. They would then submit a written report to NIST, to the validation authorities, that modules have met the requirements outlined in the FIPS 142 documentation. And those test results are documented in the submission package by the CST. If any issues exist with the CST will work with the vendor to correct the issues prior to submitting to the CMVP, the Cryptographic Module Validation Program, for certification. And once received by NIST, the NIST will post to the website as review pending. After it's been submitted and it's at the CMVP, there are 3 stages of review and certification: in review, coordination, and certification. In review is basically the NIST is validating the test results for each cryptographic module. Coordination is the CMVP will ask directions directly to the CST to verify results are accurate and complete. The CST can resubmit changes and additional validation at this point, and documentation explaining or documenting any inquiries that the CMVP have. Lastly is a certification. If the test results for the modules are determined to be compliant with FIPS 140-2 and FIPS 140-3, then the module is validated and a validation certificate is issued, and the online validation list is updated. So NIST has a convenient website for CMVP that you can go to at any time and take a look at the status of all the different cryptographic modules that have been submitted and what their status is. So remember that there is a key difference between SSDs that advertise being FIPS 140-2 ready and FIPS 140 certified. Remember that unless the drive has received its certification from NIST, NIST views the data on the drive as unprotected plaintext. KIOXIA has gone through this process several times on several models of our SSDs over many, many years and many generations of products. While deploying SED drives and FIPS drives in your data center is a great first step in protecting your data at rest, you must, extra emphasis on must, set your user authentication keys, AKs. Setting your AKs means if a drive finds its way out of your data center and into unsavory hands, the data on the drive is useless, as AE256 is nearly impossible to break. In a server with several SSDs, it can be difficult to keep track of the individual AKs unless you use a key manager. Dell EMC makes it easy with their comprehensive security key management options, paired with hardware-based integration on PowerEdge servers via ID Rack. Dell EMC is taking the guesswork and confusion out of deploying SEDs and protecting your data at rest. Earlier, I mentioned performance as being a barrier to deploying data at rest security. There are a few different methods of applying data at rest security. There are software-based encryption solutions and hardware-based solutions. Encryption at the software level is exactly that. There's a software application that is used to basically take whatever data is out on your network, and as it's being written and read from the data to the storage, it's being encrypted. It requires resources on the server, namely the CPU and DRAM, to encrypt the data as written. This increases the overhead on the CPU and DRAM and affects the overall performance of the system. Hardware-level encryption, like on SEDs and FIPS drives, encrypts and decrypts data as part of the SSD's data path and do not affect the performance on the drive or the system. We are doing a demonstration in our virtual booth this year on encryption without a performance hit, or, as I like to call it, security in the fast lane. We took a Dell PowerEdge 7525 with the latest AMD Milan processor, a hardware RAID controller capable of TCG Opal, and 2 sets of our PCI Gen 4 SSDs, one as an ICE drive and the other as an SED. We ran then a bunch of workloads, a TPC-E benchmark, MS-SQL server applications to showcase the shameless product plug, fantastic performance of our PCI Gen 4 SSDs, and the non-impact to performance when using SEDs. Here's a slide showing a high-level view of the performance comparison. So this lists the details of the configuration that we used, the kinds of comparison metrics tested, and the results at a high level. There was no performance hit on the CPU or the SSD. I've also included some performance numbers for the KIOXIA CM6 Enterprise Class SSD and the CD6 series Data Center NVMe SSDs, and a couple links and resources for you to take a look at on your own for all of our KIOXIA solutions. So, to summarize what we've covered today, data breaches are expensive. Not securing your data at rest is a huge and costly risk to your company and your customers. Dell EMC and KIOXIA make it easy to have a security strategy to protect your data at rest. And lastly, KIOXIA's PCI Gen 4 SSDs are really fast, and security is no longer a choke point. Thank you very much for your time, and thank you to Tom Hibbler for bringing his expertise. Please stop by the KIOXIA booth and ask me if you have any additional questions from this presentation and or our products, and talk to your local Dell EMC representative about how to protect your data at rest.